Hey guys, it's me, Mr. Tardy, here to finish off this section as a bit of review. So, what is it that you are going to have going on? You did fairly well on Tuesday. However, I want you to have a bit of review before you get into work. It should be really quick. Now, if you remember, our goal is to divide everything, right? So I see I have 5. I can cancel that out and make that a 1. I see got -5. -5 divided by 5 gives me a -1. And I got -20 divided by 5 gives me a -4. I got x. I remove an x. That's gone. I remove an x from x squared. That leaves me x. And I'm left with this guy. So -4x minus 1. Again, we felt fairly confident by the time we were done. Honestly, I knew you guys were leaving towards the end and I wasn't giving work, so I really just filled out more time than anything else by keeping on going. But again, I want some review. So I take a look and I see, -5, 30, and -25. I see that all of these guys can be divided by -5. And since that's the case, I'm going to do it. That's how it works. If you can do it, just do it. The -5 become a 1. 30 divided by -5 will be a -6, and -25 divided by -5 will give me a +5. X squared is gone. Okay. X squared, remove x squared, gone. X4, remove x squared, x squared. Y, gone. Y5 minus Y1, Y4. And Y3 minus Y1, Y2. You guys see it so far? I hope this video looks fine enough. If it's not, my verbalization should be getting through to you, okay? So that takes care of the first set of questions I want to ask, and it hasn't even been 2 minutes. Now, as always, feel free to pause and stop the video if you feel like you want to try it out yourself, or if I'm going too fast, definitely feel free to slow down the video and rerun it. Here, we got the same set of operations, okay? I can thicken up this line a little bit. So, I see 4, I see 4, I see -12, and I see 16. All these have 4 as a common factor, and since they do, we're going to remove 4. That's 1, that's 1, that's -3, that is 4. Simple division. X squared. Each of these guys will get divided by x squared, so that's x squared, that's gone. X4 and x squared will become x2. X6, x squared will be x4. And I don't want to forget my plus sign right there. And that's my answer. Just bring it down, put it nice and neat. 4x4 minus 3x squared plus 1 izzle. We digging it? We vibing it? I'm reading this vibe. I want to go green for my X cutter, but it's like 4 screen. Look at that. That's nice. Okay, I see 3. I see 15. I see 9. I see -24. They all have a common factor. These are the easy ones to look at. Sometimes it doesn't always come easy. But I noticed that they all have a common factor in 3, right? So -15 and 3 gives me -5. 9 and 3 gives me 3. -24 and 3 gives me -8. Then I'm going to remove x fifth, right? X minus x fifth, or x to the power of 1 minus 5. That's going to give me x -4. 3 and the 5, that is going to give me x -2. And 7 and the 5 will give me x2. I'm going to bring this down and rewrite it so it's a bit more clear. X squared plus 3x -2 minus 5x -4. And if you remember what we were talking about in a prior chapter, we really really, really, really do not like negative exponents. We use these as a representation of what they can look like because our rules and properties have to permit it, right? But if I want to give my final answer, I'm going to get rid of those negative exponents by flipping just the exponent. The variable will get flipped. The coefficient will stay the same because there's no negative exponent. Negative 8x squared, there's no negatives there, plus 3 over x squared. The negative 2 was applying to the x, not the 3. It was applying to the 2, not the 3. Minus 5 to the x, oh no, 5 over x to the 4th. The negative 4 applies to the x, not the 5, to the x. These guys are just multiplying by each other, which gives us this final answer. Can you dig it? All right. I like orange. This looks like a nice ripe orange. So I see 4, I see 8, I see 28. I look it, I check it, I kick it. All these can be divided by 4. And that's what? 7? That's 7. 7s are such weird numbers, aren't they? All right. x2, x4, so that leaves me with x2, and x5, that leaves me with x3. y2, y3, that leaves me with y, y4, that leaves me y2. And z squared, z squared, z cubed, that leaves me with z. And I'm going to bring it down, make it a lot nicer. 7, x cubed, y squared, z, plus 2, x squared, y. All right. Again, I feel like I don't want this to feel like it's getting confusing. I don't want this to be doing too much, brah. But it's straightforward once you get the habit of it. You know, I feel like you're saying either I'm completely confused or Mr. Tardy, I get this. We don't even have to do the last ones. And you're right. I mean, look, at this point, I'd like you to do the last ones because there's just 2 left. However, if you feel like you're ready and confident to go for the work, go ahead. But please watch these last couple because these are where the tricky ones come in. For example, this thing. Ugh. Ugh. I mean, what is this even supposed to be? Well, this is multiplication right here, and this is division. If you remember, when it comes to multiplication, division, and PEMDAS, it's associative and commutative, which means order doesn't matter. So, this is saying to divide and multiply, right? So let's start by dividing by the 3 and the x, and then whatever we get for an answer, we'll multiply there. That's an order of operations. So 3, 15, and 6, that's going to give me a 5. That's going to give me a 2. X and x squared, that gives me an x. X and x, just gone. Leave my plus sign. Cool. And I got 2x minus 1. Now, you need to keep a note. This whole thing needs to be multiplied. So I'm going to put parentheses around it. And, here comes that thing we talked about in the last section. The binomial times binomial. FOIL. First, outside, inside, last. Okay, 5x and 2x. 10x squared. 5x, negative 1, negative 5x. 2, 2x, 4x. 2, negative 1, negative 2. Then I simplify. 10x squared minus x minus 2. Let's finish it off with this goofy fella. Aww. That's a lot of multiplication on top. You remember what I just said? Literally just said. Multiplication and division are associative and commutative, which means that the order doesn't matter. multiply first or divide first. Take your pick. Be lazy. A proper mathematician is thorough, but a proper mathematician is lazy. They will do the minimal amount of work they need to get it done. They will take the easiest path. And I noticed this has MN, 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 and MN. Because they all have MN. Can't I just not do what I literally been doing this entire time and divide everything by an MN? Mm-hmm. Okay. So M, M. Okay, so that leaves me with M, M, gone, M, and gone. Oh. Okay. N, N. That's N. N, I'm left with nothing, so I fill that in with a 1. N, N. Left with nothing, so I fill that in with a 1. So I have Mn minus 1, Mn plus 1. And I just want you to keep this in mind for the future, as this is going to be something you see a lot in the future. Well, let's take a look. Mn times Mn, M squared, N squared. We got 2 M's and 2 N's. Calm diggity. Mn times 1. So plus Mn. Negative 1 times Mn minus Mn. Negative 1 times positive 1. Negative 1. Ooh, look at this. Mn, negative Mn. You know why I pointed out. They're going to cancel out. Gonzo. M squared, N squared, minus 1. All right. So that covers the material that we didn't cover yesterday. It's been like 12 minutes. You would have approximately 30 to 25 minutes to get your work done. Now, what I'm asking for is all 24 questions. I know that seems like a lot. Theoretically, this should take less than a minute for each question to work on. You guys, again, work together. I know you guys can work together properly, which is why I let you work together. You're not cheating. You're collaborating. You're ensuring your answers are fine. You're always getting your work down. I get it. You guys know how to do it, and that's why I like it and I allow it. So work together, get the whole paper done, and enjoy your Friday. All right. Bye-bye.